This is chapter number 6, the remaining part. Now, here, this is the formula for the voltage and the current. Basically, in this chapter, there are three types of the voltages we are using and three types of the current we are using. So, this is the number one, the instantaneous values of the voltage and the current. So, this is a first type. This is a this is the first type, the instantaneous values for the voltage and for the current. Okay, so this is the formula for the instantaneous voltage, and this is equal to V max sine omega t in the bracket, and this is the formula for the current instantaneous. This is the instantaneous current. Instantaneous current is equal to I maximum sine omega t. So in these formulas, we are using the two things. The one is a maximum value of the voltage, and the other is we are using sine omega t. So we are using sine omega t. So this omega is a angular frequency. The omega is a angular frequency, and the formula for the omega is given here. The omega equal to 2 pi f, like this. And in this formula, this one is an angular frequency, and the unit of this is radian over second. Okay, in the short form, radian over this is second. This is a unit of the angular frequency. So the angular frequency is 2 pi f, and here this f is a linear frequency. This is a linear frequency, and the unit of this f is a hertz. Okay, and also we know the relation between the frequency and the time period. The frequency is equal to 1 over t, like this. Okay, so this is another formula, and that is in the form of the time period. And by using this rule, f equal to 1 over t, we can get the value of, or the formula for the angular frequency, okay, 2 pi f, and which is also equal to 2 pi over t. This is one another rule. Now here they are telling about the frequency and the time period. So this already I told you that that f is equal to, this is 1 over t, and this is the time period. So the time period is, okay, so how to, if you need to find the value of the time period from the wave, okay, so then how to find the time period? The definition of the time period is, this is the time of the one wave. Okay, so you can see in this diagram, this is a sine wave, and if I say, okay, for example, if this here, if I take the time here, and if I say this is 0 second, and this is 100 second here, and this is 200 second, for example, okay, and this is 300 second, and this is 400 second. Okay, so this time I can write like this is in the unit of the second. Okay, so from this point, okay, from this point to this point, this is one wave, or it is a one cycle. Okay, sometimes we are saying one cycle or the one wave. So the time of the one wave, okay, so it is starting from 0 second and it is going up to 400 seconds. So this is known as a time period of the wave. Okay, so here in this case the value of the time period is coming a 400 second. Okay, so this way we find the time period value. No. Okay. So as I told you, there is a three types of the current and the voltages are here in this chapter. So this is a first type. Okay, the instantaneous. Okay, the instantaneous values. Okay, so this is a first type, and the second type is the second this is a second type. Okay, this is a second type of the values. Okay, RMS values, this is the RMS values. And the third type of the the third type is a maximum values. Okay, so we can say it is a third type. Okay, like this. So here the formula is given for the RMS current. The formula is given for the RMS. Okay, the formula is given for the RMS current. Okay, now this is a formula for the RMS current. Okay, like this. So the IRMS is equal to I maximum over root 2. So this is the way, okay, to write the formula. And also, okay, if I calculate this, the root 2, so it will come like this. Okay, 0 point. Okay, I can, if I want to write in this form, I RMS equal to I maximum divided by root 2, or okay, or 0.707 multiplied by I maximum. So okay, so I can write this way also. Okay, both the ways are there. Okay, I can write in this form, or I can write in this form. Okay, so this is the rule in the form of the in the form of the RMS. Okay, and also, okay, and at the same time I can write the formulas in the maximum form. Okay, so how to write this maximum form? Okay, so from this equation, if I take the I maximum, okay, if I take the I maximum one side, okay, I can write this is the current maximum equal to this is root 2, and this is multiplied by this is I RMS. Okay, so now the equation becomes in the form of the maximum current. Okay, so this is the maximum current equal to the root 2, and this is I RMS. So I can say this is a third form. Okay, so in the same way, there is a formula for the, okay, there is the same way, the formula for the voltage, the RMS voltage. So there is a formula for the RMS voltage. So the RMS voltage is equal to the maximum voltage divided by root 2, or okay, or 0.707 V maximum. Okay, or if I want to write the voltage in the form of the maximum, I can write like this. Okay, so like this is the V maximum, and here this is V maximum is root 2. Okay, then multiply by this is VRMS. So this is the voltage, okay, in the form of maximum rule. Okay, like that. Now, so here this is a phase of the AC. Okay, or sometimes we are saying the phase angle. Okay, the phase angle. Okay, the phase angle of the AC. So sometimes we can write the sine wave in the form of the angle, and this is always fixed. Okay, okay, always fixed. So for the one cycle, okay, the phase or the angle. Okay, so if I say the angle of, okay, the angle of one cycle. Okay, what is the angle of the one cycle or the one wave? So this is always, okay, this is always 360 degree, always. Okay, so if I say what is the angle of the half wave? Okay, so for the half wave, the angle of the half wave is equal to the half of this. Okay, so this will be always it is 180 degree. Okay, so it is represented here. Now, okay, so now this is one wave. Okay, so like from here to here, okay, from here to here, this is half wave. Okay, from here to here, half wave. So what is the angle of the half wave? The angle of the half wave is pi. Okay, it is written here pi. So what is the meaning of the pi? The meaning of the pi is 180 degree, and it is starting from 0 degree and going to pi. Okay, so this is a angle, okay, the phase of the half wave from here to here. Now if I go downside, okay, because another half wave, this is also the half wave. Okay, so this is also the half wave downside, and the angle, okay, it is starting pi here. Okay, it is starting pi, then okay, this is the maximum point, it is coming 3 pi by 2, and here, okay, and here it is coming 2 pi. Okay, so this is going from pi to 2 pi. Okay, pi to 2 pi means, okay, what we have to do, then 2 pi minus pi, okay, it will come pi. Okay, so pi. So the meaning is the phase angle of this is pi. Okay, pi, or it is 180. Okay, so it is like that. So the meaning is from here to here, this is 180, and from here to here again, this is again 180. Okay, so this is total, okay, 180 plus this is again 180. So the angle of the full one wave is, this is 360 degree. Okay, and 360 degree, okay, this is equal to 2 pi, and this is the angle. Okay, this is the angle in the, if when we are writing, when we are showing the angle in the pi, so this is in the unit of radian, and here this is in the unit of degrees. This is degrees. Okay. Now we can, okay, we can write. Okay, so here, before I told you, this is the formula. Okay, this is the formula for the instantaneous voltage and the instantaneous current. Okay, this formula. Okay, we are talking about this formula. So here we are in the sign. We are writing the omega t. Okay, so it is in the form of the time. Okay, it is in the form of the time. So the same formula I can write in the form of the phase angle. Okay, so the omega, okay, this is the angular frequency multiplied by the time, this is equal to the angle, the phase angle. Okay, they are same meaning. So this is the, I can write the this is the instantaneous. Okay, this is the instantaneous voltage. Okay, v equal to v maximum sine omega t. Now this omega t is equal to, okay, this is in the form of the time. Okay, but this I can write in the form of the phase angle. Okay, so you can see here, okay, you can see in this formula, the instantaneous voltage, this is instantaneous voltage is equal to v maximum sine theta. So here, this theta is what? This theta is a phase. Okay, this theta is a phase, or and we are saying the phase angle of the wave. Okay, phase angle of the wave. Now, okay, so here there is a one question. What the question is saying? The question is saying, for a particular device, okay, for a particular device, the AC voltage is 120 volt. So the value of the voltage is given. Okay, there is a one is, because if we are saying in this chapter the device. Okay, so no need to say, okay, no need to say like this is AC device, because we are studying only AC. Okay, so it is not a DC device, AC device. Okay, So they are saying AC voltage. Okay, so this is the AC voltage given, and the value of the voltage. Okay, and the value of the voltage is given how much? The value of the voltage is given here. This is 120 volt. This is given, and the AC current is 10 ampere. Okay, and the AC current here, this is 10 ampere. These two, okay, the data is given. Now they are saying what are their maximum values. Okay, so here I want to tell you I want to give you one information here. When the question is actually in this chapter, there are three types of the voltages they are discussing. Okay, the one voltage is, okay, the one voltage is, this is an instantaneous voltage. Okay, it depends upon the time. Okay, this is the instantaneous voltage. And the second voltage is the RMS voltage. Okay, root mean square voltage. And so this is the second type. And the third type of the voltage discussed in this chapter, that is a maximum voltage. Okay, three types are here. Now, okay, so what you have to, okay, what you have to note in this question. Okay, sometimes the question will not say, okay, what kind of voltage is this. Okay, for example, now here they are saying the AC voltage is 120 volt. Okay, now this voltage, this 120 volt, is this instantaneous, or it is RMS, or it is maximum? Which value? Okay, so this is a rule. Okay, the rule is, if the question is not telling the type of the voltage or the type of the current, so you have to consider this is a RMS voltage always. Okay, and this is a RMS current always. Okay, so the meaning is the value of the RMS voltage is 120 volt, and the value of the RMS current is 10 ampere. Now they are asking, okay, what is the value of the maximum value? So, okay, so I will write the formula for the Vmax. Okay, now this is the V maximum. Okay, and the V max formula I'm writing. Okay, so this is root 2 and multiply by, this is V RMS. Okay, so here this will be root 2. Okay, this will be root 2, and this will come 120 volt. Okay, I'm taking the value from here, and if I calculate, okay, in my calculator, so it will be, okay, this will be root 2 multiplied by 120, and so this will come 169. Okay, this will come 169.7. So this is 169.7 volt. So this is the value of the V maximum. Okay, maximum voltage is, it will come 169.7 volt. Okay, so in the same way, okay, so in the same way they are asking what is the value of the I maximum. Okay, what is the value of the I maximum? So I will write the formula for the I maximum. So the I maximum is, that is the root 2 and multiply by the I RMS. So this is the root 2. Okay, what is the RMS value? The RMS value is 10 ampere. Okay, so I will write here, 10. So this will be around 14 point something. Okay, 14 something like that. Okay, so this will become ampere. Okay, so this way, okay, so this way we have to find the answer. Okay, so what, okay, so what information you have to, okay, you have to keep in your mind, you have to keep in your mind. Okay, so what we are getting, okay, from this question, sometimes, okay, if they say this is the voltage, okay, AC voltage. Okay, so it means the AC voltage means this is RMS voltage. Okay, if they say this is a AC current, okay, they are not saying, the question is not saying this is what type. Okay, so you have to, okay, so you have to consider this is RMS current always.